Hi to all. In this brief video, we will cover a two-step dividend discount model, and I hope this is helpful when working with the problems we have in the practice quiz and later on in the quiz. So we just have this problem, and as it is always a good practice to just type all of the variables once you see the problem. Just type everything you are given in the problem, and I can just see this company just paid a dividend of $2 per share. So if it just paid the dividend, we're assuming then this is D0, the dividend that is happening in period zero. Period zero is today, and it's $2. And now the analysts, right, are expecting this dividend to grow at 10% per year for the next 3 years. So this is a rather short period of time in which the company will grow at a supernormal, at a accelerated growth, right? So let's call it supernormal dot G, that supernormal growth rate, and let's say this is 10%. After that, and this is very important for valuation because we assume firms are on ongoing concerns. So we are assuming that firms are leaving uh, for the foreseeable future. They will be operating. They will not cease to exist. So then we always need this stable growth rate that the firm at which the firm will continue growing for the foreseeable future, whether it's higher or low. But we need that rate when we are working in valuation. Okay, so this is going to be the long-term growth rate, and it's at 2%. And then the required rate of return, which is a 5%. And this is usually in the dividend discount model, this rate is usually the one that we calculate using the capital asset pricing model. So now that we have all of the inputs, let's get, and if you have not seen the previous video on the one-step DDM, which we solved here, right? And I'm going to rename this one step. Just go back and watch it so you will understand. I don't need to do this long approach. I can directly jump into the use of the formula. So now we have D1, and as you may know by now, D1 is the most important thing. We cannot do anything with the dividend that this company just paid, but we need to work with the future dividends, and especially we are concerned about the first dividend, the dividend we are expecting um, by 1 year from now. And that dividend we can calculate it in the following way, which is we know that during the next 3 years, dividends are going to grow at a 10% rate. So the next dividend will be equal to the dividend the company just paid times a 10% and considering a 10% increase, which is 1 plus 10%. Okay, this is exactly the same as just saying 2 plus 10% times 2. So 2 plus the 10% of 2. So in other words, you're allowing the dividend 0 to grow by 2%. And now we have 2.2. That's D1. So now this is the tricky thing here. In the previous problem, in the one-step dividend discount model, we would normally use dividend discount model. Let's try to do so, which is price is equal to D1 divided by R minus G. Let's try. Price will be equal to D1 divided by R, 5% minus G, 10%. But now we are running into some complications because we have two um, growth rates. Well, because we're using the one, if we try to use this 10%, we will have a problem. And I will write this in numbers rather than in formulas. We will have 2.2 divided by R, 5% minus 10%. You can clearly see that the denominator will be a negative number, right? And this price will be negative, and there's no way that a price can be negative. So there are some issues, okay? Now let's keep in mind we can only use the dividend discount model if the discount rate is greater than the growth rate. Fix this, growth rate, okay? Now, in many instances, the growth rate can be higher. However, in many instances, the growth rate is higher. Let's think about Tesla, for example. Okay, these companies are at an accelerated, constant growth, and then we are seeing this huge growth occurring every year, or accelerated growth occurring every year. And therefore, if you look at the dividends or the cash flows, in case of Tesla, we don't have dividends, but we have, uh, if you look at the growth in the revenues or in the earnings or in the cash flows, you will see that these firms are growing rapidly. And this growth rate may be higher than the discount rate. So, what do we do with these firms? Well, there's a key uh, piece of information here, which is the dividends are expected to grow at a 10% for the next 3 years and then 2% thereafter. So, we will have a problem. The growth is higher than R only during the next 3 years. Okay, then after that point, it comes down to 2% and we can use the DDM. Okay, there we go. So the way to work with this is the following. Well, we will calculate the dividends in the next 3 years manually. And let's keep in mind that price, I will go back to the first video, right? Price is just the sum of the values of the expected future cash flows, right? So what we will do is we cannot use this shortcut provided by the dividend discount model. So we will work with these dividends in the first 3 years manually, and then we will work with the dividend discount model uh, starting on year 4 and thereon, and we don't have to do these calculations manually starting on D4. So we only need to do these calculations manually for D1, D2, and D3. Okay, so let's keep in mind, if we look at the previous video, we just calculated the present value of all the future dividends. So what we will do in a two-step dividend discount model is in this case where we have a 10% growth rate over the first 3 years, we will get these three cash flows manually, and then we will implement the dividend discount model formula starting in dividend 4. So we will have this formula giving us the present value of all these future cash flows, but not the present value of these first three. These first three, we will solve them manually. So what is the first dividend? Well, we already have it here, 2.2, or just to refresh our memory, this is just D0 multiplied by 1 plus this 10% growth rate, because that is the growth rate for the next year, year 2, and year 3. Then in year 2, we expect this dividend 1 to grow once again by a 10%. And in year 3, we expect this dividend to grow once again at a 10%. So the company is growing at a rate that is quite accelerated. And because this growth rate is actually higher than R, we cannot use dividend discount model. However, starting on the fourth dividend, okay, so look back. Let's look at the question again. Analysts expect the dividend to grow at a 10% per year for the next 3 years, and then 2% thereafter. Thereon, so starting in dividend 4, this fourth dividend will grow at that 2% and no longer at the 10% rate, because at that point the company reached this stable stage in the business life cycle. So we take this previous dividend in year 3 and then we multiply by 1 plus the 2% rate. Let's lock this and then the dividends are going to grow at that 2%. Let's do let's delete these numbers, and then let's do it from here. Then this dividend will grow once again at that 2% rate, and now we can lock it. So we can scroll this down, and then the dividends will continue to grow at a 2% for the foreseeable future. Because you already saw, I do not need to do this. We will get the present value. If we get the present value of all of these cash flows moving forward for the foreseeable future, we will we would get the price resulting from this long-term component, let's call it like that, of this value of the valuation of this stock. But because we have a shortcut, as a matter of fact, let's give it a try. So let's take the long approach, which is exactly what we had done before, and let's look at 300 years. Okay, then the good thing is you will be able to take the shortcut, and you don't need to take this long approach. But just to illustrate this quite clearly, if we just scroll this, we know how to do this from the past video. Right now we have the future dividends until the year 336. Now, what we did before is we got the present value of each of these dividends. So present value of, let's start with dividend 1 divided by 1 plus then the discount rate. This is what we use to get the present value. We lock this rate to the power of, no, let's click here on time, and let's not lock this one because we want to scroll it down, and we want that cell to update as we scroll down. Now, if we scroll down during the first years, we have the present value of these dividends over the first 3 years of the company. If we add them up, this is the price of, and I'm going to quote in quotes, price of first 3 dividends. Okay. But the price of the stock also includes the quote unquote price of the dividends for and they're on all the dividends forever. So we need to get those prices. Now the good thing is we can keep scrolling down. Let's keep this because I have this space here. And now we have here the present value. Let's look at the formula again. This is just the dividend 4 divided by 1 plus r to the power of time, which is 4 now. And if I scroll this down, now these are all the present values of all the dividends starting in dividend 4 and all the dividends moving forward forever. I'm going to add another space here, and then I'm going to sum all these present values, right? And we end up with this price. Now, this is the price, and I'm going to make this column wider just to have more space. This is the price of dividends 4 and thereon, which we know by the way, we already know that these dividends are growing at a 2% only, a growth rate of 2% only. Now, the price of a stock is the summation of these two things. So the price of a stock, and I will move here, is simply the summation of the price, quote unquote, of the first 3 dividends we got manually, and the price of the four of dividends 4 and all dividends thereon. We add these two, and that is the price of a stock. But this is a very long approach. So let's make it shorter and simple. We cannot use the dividend discount model here because the growth rate is greater than the discount rate. So we cannot use the dividend discount model. The dividend discount model cannot be used when growth rate is great, when G is greater than R. However, we can't use the dividend discount model at this point to get the price of these dividends at this point in time. Okay, so let's confirm this. And now what we will do is the following. Let me use this formula here. Price, and now I'm gonna price at T4. So the price we will get is the price as if we are standing and our D1 is D4 actually. Let me make it more clearly. So we have this formula. We cannot use it because D1, D2, D3 are growing at this growth rate that is greater than the discount rate. But let's assume we now change it to D4. Now the only change we have to make here is now we would get the price at time period 3 and instead of the price today. That is an important distinction. Okay, so once again, we change this formula and we will start with the first dividend that grew at this long-term growth rate. But because we changed the formula, we're changing it from D1 to D4. Now from price times 0, which is basically implied before, right? Now we have price at time 3. Okay, let's use the formula now. So D4, price at time 3, will be equal to this dividend 4, which we have here, divided by R 5% minus G. Now, long-term growth rate is smaller than R, so we can actually use it. And we have this 90. Now, let's keep in mind, this is price at time period 3. So now let's get price at time period 0, which is today. And we just take this price at time period 3 and we discount it we bring it to present value. So the price divided by 1 plus R to the power of 3, because this price is price in period 3. Once we do that, you can quickly see that this price is very similar to the one we got from the long approach, right? If I continued a couple of hundred more years, the two prices would have matched exactly, would be identical. Okay, so now we have this price from dividends 4 and thereon using this shortcut instead of having to calculate the present value of 400, 300 dividends as we did here in the long approach. Okay, so finally, what we do is this is the price, and let's keep in mind this is the price today, T0, of dividends 4 and thereon. So now we do have to add, so the total price of the stock will be this price plus the price of the first 3 dividends which we have here. And we end up with the same price we had in this long approach. Now in the next video I will repeat this exercise, but only doing this in the short approach. If you would like, if you're a little bit confused by the long approach and the short approach, let's just watch the next video. But in this video you can clearly see the link of what exactly we are doing and how and why we're doing it. Okay, so thank you so much. And then if you're still unclear about this shortcut formula, let's just watch the next video. Thank you for your attention.